Hey everyone, this is Mr. Dufresne here, and welcome back to class, right? It's been a little bit. I hope all of your families are doing well. Before we start today's lesson, I wanted to talk a little bit about exponential functions. We've discussed exponential functions in this course before, and when we talked about that, one of the things I said was, oh, this is really applicable to bacterial growth and how bacteria multiply, that you start with one bacteria and it doubles into two and then doubles into four. Well, viruses actually spread in a similar way. Each kind of virus has something called an R0 factor, which is the number of people that each person is expected to infect when they are infected. So coronavirus has an estimated R0 factor of anywhere from 2 to 3. Okay, it's still being figured out, and different sources have different opinions on this. But let's just go ahead and say, let's pretend, for example, that coronavirus has an R0 factor of 2. Okay, so what that means is every person who gets infected by a coronavirus will on average infect 2 other people. Now, not every person is going to infect 2 other people, and some people will infect many more people, but on average, 2 people. So that means, let's just use circles to represent people. Here's my first person who gets infected, okay? And that person is going to infect 2 people. And those 2 people are going to infect 2 people. And these 2 people are going to infect, or these 4 people are going to infect each 2 people. And you can see the number of people who are infected is growing very quickly. And we model this kind of growth where things keep doubling over and over again as an exponential function. In this case, it's f of x is equal to 2 raised to the x power, okay? And so when you look at the growth this way, and this is a simplified model. If epidemiologists have much more advanced formulas than this, but this is kind of a nice rough way to look at how coronavirus is spreading. So if we make a little function table here and do our x values, if x is, this is like periods of time and how this is spreading from more and more people getting it over time, okay? So time, let's say time is 1 for now. At 1, well, 2 to the first power is just 2, and then time is 2, and 2 squared is 4, and 3, 4, 5, 6, 7. And if you look at the f of x, 2 to the third power is 8, then 16, then 32, then 64, then 128. And so, one thing I'm hearing a lot from people that I talk with about coronavirus, they look at the early numbers and say, oh, it's only 40 cases. What's the big deal? And that's like this part of the number set right here. Like, oh, what's the big deal? Only 16 people have coronavirus. Only 32 people have coronavirus. And then all of a sudden you get these big jumps down here, right? 64, 128. Let's add some more. So then we got 256, 512, 1024, 2048, 4096. Right, that's some pretty big growth there, right? And we went from growing from 4, 8, 16, just growing by 4 and then 8, to growing by thousands at a time, thousands every day. And that's why you're seeing things like, oh, the number of coronavirus cases within New York, went up, doubled within 4 days. Well, yeah, that's what you expect with an exponential function. And so, I want to bring this to your attention because I want you to understand how applicable the things that we learn in this class are. I also think it's worthwhile to mention that coronavirus or viral infections, epidemics like this, are not truly exponential functions, right? Because if I make if I make a graph of this over here, the exponential function looks something like this, right? If you recall from class, it grows very quickly, and then it doesn't peak, it just rises at a very quick rate to the point where it almost looks asymptotic. But this isn't realistic because there are two things that will slow down the exponential growth eventually in an epidemic. One is there are only so many humans that can get infected, right? And the second is that as people get infected, people can't get reinfected. I mean, sometimes they can. There's a percentage, I think less than 10%, that can get coronavirus more than once due to their immune systems insufficiently fighting it off. But most people are not going to get reinfected. And so, really, coronavirus or any kind of viral infection like this, any kind of epidemic, ends up looking more like something like this. Okay? Where this is our peak, where we hit the maximum number of people. This is where Italy is right now. If you're paying attention to the news at all right now, they have just started coming down to this part of the curve right here. And different things that we do can do something called flattening the curve, right? You might say, right now we're not in school. You might think, well, what's the point? What's the difference? Eventually, we have to go back out into the world, and won't we just get infected then? And maybe that's true, but there's a difference between that peak and this peak right here. Okay, this one is many more people getting sick every single day, and this is fewer people getting sick every single day. They are both peaks, and let's pretend that these both contain the same number of people overall, but the difference is that hospitals can handle this shorter peak much more easily than they can handle this larger peak. And so the goal of closing schools, closing restaurants, banning people from gathering in groups more than 10, and things like that, is to flatten this peak as much as possible. Okay. On eCampus, I posted 2 videos about the math behind epidemics. They're both done by someone named 3 Blue 1 Brown, who is like a math teacher hero of mine. I think he just gives the best math explanations that can possibly be done on a variety of subjects. He revolutionized my understanding of calculus and linear algebra, and so I've linked him to you guys because he's going to explain some things to you. For those of you who are interested, it's not required for the class, but if you're interested in what's going on with coronavirus and what we really need to do to make sure as few people as possible get hurt by this, I strongly recommend checking out these videos because they will help you understand through simulations what's important. If you go to the extra information at the bottom of the second video, he also links to several articles that allow you to view more simulations or play with your own simulations. It's something I think is pretty interesting. So I just wanted to give you guys that opportunity. You all should have received an email from me by now about expectations about the course through distance learning through the next 2 weeks at least. And in fact, my goal is to keep things as normal as possible. I still want you to be listening to me every day while I explain the math that we do. I am going to be printing off the notes, just like I did right here, for us to go through tonight. And you will still upload everything to eCampus. The only major difference is that you will be doing everything from home, and you won't get to see me face to face. I've opened the discussion board on eCampus for you to ask questions on if you have questions about the work here, I ask that you please send the questions to the discussion board instead of emailing me. And the reason for that is, if you have a question, it's very likely that other students also have that same question. And it is better for everyone if you can provide everyone with your answer that you get through asking me on the discussion board. Okay, so let's go ahead and start working on this. As always, my name is Key, and today's topic is 8.2, adding and subtracting rational expressions. Kind of room there, but there it is. And of course, this is Algebra 2, and the date, let's just call it 3:30, because that's when you should be doing this and submitting it. Oh, and one nice thing about the way we're running things for the next 2 weeks is that everything's self-paced. So I'm going to be uploading all of the lessons this week before the week is over, hopefully by tomorrow. And I'll also have all the assignments on, and I'll have them all unlocked. I won't lock them day by day. And the test will also be unlocked. And so if you were an ambitious student or someone with just a lot of time on your hands, you could, in theory, work through everything very early and then have less to be concerned about. So the course is going to be extra flexible. Or if you're someone who just has maybe you can't hop on here the first couple days, but you can get on Wednesday or Thursday, then you have that available as well. Okay, so I think kind of my plan is to go through the odds, I think, and then leave you guys the evens. And if you guys get stuck on one of the evens, then you can ask on the discussion board in eCampus, and I'll work you through things, okay? So today we're talking about adding and subtracting rational expressions, and you can see there are 3 steps. 1, rewrite the problem using a common denominator. 2, combine the numerators and keep the common denominator. And 3, simplify the remaining expression. So in the simplest, just think back to like middle school when you learned how to add fractions, and you had things like 3/8 plus 1/8. How did you do 3/8 plus 1/8? Well, you just add the 3 and 1, keep the denominator of 8, right? So 3 plus 1 is 4 over 8. And that's your answer, and that's all you have to do. It's the exact same thing we're doing right now. It's not any more complicated than that. So on this first problem, these both have a denominator, 4a squared, and we have 13a plus 5a. Well, 13a plus 5a is 18a. So now I have 18a over 4a squared. Now this isn't a sufficient final answer because we want to reduce our answer. Okay, so we have an a over an a squared. If you have a over a squared, we can cancel one of those a's and just have an a left in the denominator. So this a cancels and this squared cancels. Also, I have 18 over 4. I can divide both of those by 2, so I have 9 over 2. So I have 9, 2. So my final answer is going to be 9 over 2a. And my inclination is to say, any questions? But you can't ask me questions right now. So if you have questions, put them up on the discussion board. Big thing, when you put things on the discussion board, it's really helpful if you put a picture. Maybe upload a picture from your cell phone or something of you doing the work, so I can tell you what's going on. When I respond, I will probably take out a piece of scrap paper and work out the problem with some notes to help guide you, because it's very difficult to do math through verbal description alone. It's not something I'm fond of, at least. Alright, so moving on to number 3 here. Notice these have y squared minus 9, y squared minus 9, so I still have the same denominator. So let's just add these numerators. Y squared, I don't have any y squareds over here, so I'm just going to write that y squared again. Then I have 8y plus 2y. 8 plus 2 is 10, so that's 10y, plus 21. And this is now over y squared minus 9. Okay? So when you're in this situation, we want to see, can we factor this, and can we try and cancel something out? So if I try and factor my numerator here, y squared plus 10y plus 21, I want to make a little AB table. Right, and a plus b is 10, a times b is 21, and so I want something that adds to 10 and multiplies to 21, and that occurs to me to be 7 and 3, right? 7 times 3 is 21, and 7 plus 3 is 10. So this becomes y plus 7, y plus 3, over, and right away when you see y squared minus 9, you should notice that y squared is a perfect square, and 9 is a perfect square, and this is subtraction. So this is a difference of squares and factors to y plus 3, y minus 3. And now notice we have two y plus 3's. And so my final answer is y plus 7 over y minus 3. And I can't simplify it any further. Remember, you cannot divide these y's individually. That's not a thing. Okay. Let's do number 5. So this can be tricky. Notice there's a minus sign right here. If there's a minus sign between our fractions, you are subtracting this n and you are subtracting this 1. So you see we have same denominator, so that's not a concern. N squared, there's no n squareds over here, so I have an n squared. Now I have 3n minus n. 3n minus n is 2n. And I have negative 7 minus 1. Negative 7 minus 1 is negative 8 over n squared plus n minus 6. Okay, now we're factoring, and this is going to factor into n plus 4, n minus 2 over n plus 3, n minus 2. And then you see I have n minus 2 over n minus 2. These cancel. And so my final answer is just n plus 4 over n plus 3. Okay. So those are the easier examples to do. All you really have to do is combine the numerators and then factor. When we have unlike bases, we have to get like bases. And to get like bases, or to get common denominators, as I usually say, we have to take each denominator and multiply the other fraction, top and bottom, by that denominator. Or at least multiply something that gives them the same denominator. So here I see 2x and 3x. And the lazy way to do this, which is usually my preference, is to just multiply each one by what the other one's missing. Okay, they both have an x, so I'm not going to multiply by x again. That would be silly. But this one has a 2. So I'll multiply my second fraction by 2 over 2. And my second fraction has a 3 in the denominator, so I'll multiply my first fraction by 3 over 3. So I'll write this as 3 over 3 times 15 over 2x minus 16 over 3x times 2 over 2. And so when I do this, let's see what I get. 3 times 15 is 45 over 3 times 2x is 6x minus 16 times 2 is 32 over 3x times 2 is 6x. So now I have 45 over 6x minus 32 over 6x. So this becomes 45 minus 32. That just gives me 13 over 6x. And we're done. So, not too bad. Again, the big key here is just make sure they have the same denominator by multiplying each fraction by what the other one is missing. Don't skip steps and try to do it all in your head. Work it out step by step and things will go okay. Alright? Hey, and the nice thing about me recording the lectures is you can always pause if I turn the page too fast, right? Okay, so let's do number 9 now. So on number 9, I have 5k minus 10. Now one thing I'm going to notice is if I have 5k minus 10, I can factor out a 5 from this. So it's 5 times k minus 2. Well, if it's 5 times k minus 2, notice I have k minus 2 right here. So I don't need to go through the trouble of multiplying this by k minus 2 over k minus 2 and this by 5k minus 10 over 5k minus 10. That'd be a lot of work. All I have to do is multiply my second fraction by 5 over 5. And if I do that, let's see what happens. So if I multiply this by 5 over 5, okay, now I have k squared plus 16 over 5k minus 10 equals, minus, not equals, 4 times 5 is 20 over k minus 2 times 5 is 5k minus 10. Okay, so now I have the common denominator. I can do 16 minus 20. 16 minus 20 is negative 4. So now I have k squared minus 4 over 5k minus 10. I know my handwriting is a little wobbly here, and I apologize for that. The desk I'm writing on, you can see, is one of those kinds of wooden desks that have all the little notches in it everywhere, and that's like how my laptop and everything is set up. So sometimes it's my pen's just going to catch on those little ridges within the desk and create that effect. Okay, so continuing the problem we left off before. K squared minus 4, you should recognize as a difference of squares. So it becomes k plus 2, k minus 2, over, and I already said 5k minus 10 is 5 times k minus 2. So this becomes 5 times k minus 2 when I factor out the 5. And look, I have k minus 2 over k minus 2. These cancel. So my answer is just k plus 2 over 5. Number 11. So I think before you do anything with these, if you have a trinomial like this, factor it and see what it looks like. So I know that if I have x squared plus 5x plus 6, let me do this off to the side here, x squared plus 5x plus 6, I know that factors as x plus 2, x plus 3. Well, this has an x plus 2. My second fraction has an x plus 2. So what's it missing? It's missing an x plus 3. Then it'll be x plus 2, x plus 3, just like this is x plus 2, x plus 3. So I'm going to multiply this fraction by x plus 3 over x plus 3. And so now what do I have? X squared minus 5 over x squared plus 5x plus 6 plus, and I should have written this as x plus 2x plus 3 really, but it's okay, I'll get on the next step. 1 times x plus 3 is just x plus 3 over, and for now I'm going to write this as x squared plus 5x plus 6 just to make it clear that these are the same denominator, but again I'll factor it to x plus 2, x plus 3 in a second. And so if I combine like terms, I have x squared, right? X squared. Then I have a plus x, and then I have negative 5 plus 3, which is minus 2, over x plus 2, x plus 3. See, I kept my promise. I factor it in the next step. This right here is going to factor as x plus 2, x minus 1. So this is x plus 2, x minus 1, over x plus 2, x plus 3. And now look, I have x plus 2, x plus 2, and they cancel. So now I have x minus 1 over x plus 3. Okay. Number 13, you see, I'll move this up. I gotta keep track of that because I don't have you guys to tell me when I'm off the page anymore, right? Okay. So I have w plus 1, w minus 7. If these are binomials, right, there's nothing I can do to like factor these and make them like each other. So this is just an unfortunate situation where I have to multiply this fraction by w minus 7 over w minus 7, and this fraction by w plus 1 over w plus 1. So let's do that. You know, I'm just going to w plus 1 over w plus 1, and over here, I'm going to kind of write out on the sideline to save space, w minus 7 over w minus 7. So if I multiply these, I'm going to distribute the 5 here to w minus 7. 5 times w is 5w. 5 times negative 7 is negative 35 over, and then I have w minus 7, w plus 1. Let's just keep it like that. W minus 7, w plus 1. There's no reason to distribute and then refactor later, right? That's just silly. Plus, and now this is 8 times w plus 1. So that's 8w plus 8 over w minus 7, w plus 1. W minus 7, w plus 1. And so now when I add these together, 5w plus 8w, that's 13w. And let's see, what's negative 35 plus 8? Negative 27? Yeah. Boom. I think that's as far as it gets. I don't think it gets any simpler than that. All right, you can't factor out 13 or anything like that. So we'll just call it a day on that problem. All right, last problem for me, and then I'll leave you guys the evens to work through. So let's factor out these denominators and see what happens. I'm going to first this p squared minus 8p plus 15. Like, the thing is, when you see this 4p minus 20, there are different things you can do with the 4p minus 20, right? Like, I could factor out a 4, I could factor out a 2, for example. I could leave this 4p minus 20. I could even reduce this fraction, right, by dividing all these by 2. So I have lots of options, okay? I don't like options in math. I like things to be really clear and straightforward. So I see p squared minus 8p plus 15. This can only be factored one way. So let's start by factoring that. What does p squared minus 8p plus 15 factor into? Well, it factors into p minus 5, p minus 3. Is that helpful? Yes, it is. Because I know if I factor out a 4 from 4p minus 20, I have a p minus 5 here. So let's do that. So now I have 2 factor out the 4, p minus 5, plus p minus 6 over p minus 5, p minus 3. Okay, so now where does that leave us? This fraction is missing a p minus 3. So I'll multiply this by p minus 3 over p minus 3. This fraction, what's it missing? This has a 4. My first fraction has a 4 in the denominator. So my second fraction I'll multiply by 4 over 4. Let's do some math. P minus 3 times 2 is 2p minus 6 over 4 times p minus 5 times p minus 3 plus p minus 6 times 4 is 4p minus 24 divided by 4 times p minus 5 times p minus 3. Okay, now we're in a position where we can combine some like terms. 2p plus 4p is 6p. Negative 6 plus negative 24 is negative 30 over 4 times p minus 5 times p minus 3. And now again, 6p minus 30, what can I factor out here? I can factor out a 6. You factor out a 6, this becomes p minus 5. So I'm going to factor out a 6, and I have p minus 5 over 4 times p minus 5, p minus 3. And now what do I got? My p minus 5's cancel, that's nice. 6/4 reduces to 3/2. So I have 3 over 2 times p minus 3. So my final answer, which I'll write over here, is 3 over 2 times p minus 3. And if you distribute that to 3 over 2p minus 6, I don't really care. I'm fine with either of these as answers. I'm not super picky about things like that. You guys know that. So that's what I got for our first lecture. I hope you guys enjoyed yourselves as much as I did, and I will see you all tomorrow for lecture number 2. Number one thing to take care of today is to make sure you go on to eCampus and take the quiz about your distance learning expectations. Okay, so I put a quiz on there, and that's to make sure that you all are aware of what's expected of you, and once you take it, you can't say you didn't know. And if you don't take it, I'll be calling your parents to harass you and say that you should be doing your schoolwork. Anyway, I hope everything's going well with you guys. Have a good evening, or whenever you watch this, afternoon. Yeah, have a good one. Bye.